Okay, welcome to the fifth video of this sequence going through the Core 1 2015 paper. We're up to question 5, which is this one where we've got an equation where p is a constant we don't know, but we know the equation has no real roots, and we need to show that p satisfies p squared minus 6p plus 1 is greater than 0. So the first kind of hint about what we need to do comes from this has no real roots part. So if they're telling us it has no real roots, that means if I drew out the equation, I don't know what this would actually look like, but a rough sketch of it would be something like this, where it doesn't cross the x-axis. If it doesn't cross the x-axis, that means the discriminant, b squared minus 4ac, must be less than 0, because if it has no real roots, the discriminant is a negative, which means you can't square root, so no real roots. So in that case, if we apply this to our formula, we know that a is p minus 1, because that's the coefficient of x squared. We know that b is 4, and we know that c is p minus 5. And we know it's less than 0 because it has no real roots, so we just substitute these bits in. So b is 4, so 4 squared, minus 4 lots of a, so p minus 1, multiplied by c, p minus 5. That is all less than 0. So if we just simplify this a little bit, 16, and then I think it makes sense to expand out the double brackets next. So p times p is p squared, p times minus 5 is minus 5p, minus 1 times p is minus p, and then minus 1 times minus 5 is plus 5, and that's still less than 0. And then if we multiply, well, let's simplify the bit inside there first, so p squared minus 6p plus 5 is less than 0, and then multiply out the 4, so we get 16 minus 4p squared, minus 4 times p squared. Then we do minus 4 times minus 6, so that gives us plus 24p, and then minus 4 times plus 5 is minus 20, and that's less than 0. Okay, let's kind of gather that all together. So we've got minus 4p squared plus 24p, and then 16 minus 20 is minus 4. It's less than 0. So if we look at this, it's kind of not that nice to factorise because we've got this minus 4p. So if we divide everything by minus 4, excuse the rubbish arrow, so I'm going to divide everything by minus 4, which would give us p squared minus 6p, because we're dividing by a negative, and then plus 1. But hopefully you remember, if I divide by a negative number, I need to swap round the inequality sign, which gives us this. Okay, so now p squared minus 6p plus 1 is greater than 0, and I think that's all we needed for part A. Yep, so there we go. Part B, hence find the set of possible values of p. So that's essentially asking us to solve this inequality. It's important to notice if you couldn't do part A correctly, you would still get all the marks for part B because they've given you the finished equation, and obviously you just use that one and then find the values for p. So the first thing to do with this is to factorise it. So p and p, and then we need two numbers that multiply to make 1 and add to make 6. Actually, it won't factorise, will it? Because we need two numbers that times to make 1, so that can only be 1 and 1, and they can't make 6. So we actually can't factorise this one. So since this won't factorise, we need to probably complete the square. So let's complete the square on it. So p minus 3 squared, so just half the 6. We're still going to have the plus 1, but we need to take away the square of this, so minus 9 and then plus 1. Okay, so we got the minus 9 by doing 3 squared. Simplify that a little bit. P minus 3 squared, and then we have to have a minus 8 greater than 0. And from that we can solve it. So we need to add 8 to both sides. So we got P minus 3 squared is greater than 8. And then square root. So P minus 3 is greater than root 8. So P is greater than root 8, well, plus or minus root 8 plus 3. And that gives us our solutions. Now, that's not quite going to be enough for the answer, though. We need to figure this out a little bit. And hopefully you remember whenever we're trying to solve a inequality, we need to draw a little sketch to help us. And if we go back up to here, we're looking for this bit where it's greater than 0. And if we think about what that would look like here, well, this is our 0 line, where y is 0. So the parts of the graph where it's greater than 0 is this section on the outside here, and this section on the outside here. And this is going to be given by our solutions that we found just here. So I'll just draw these in. So this side is going to be, if I just rearrange this a little bit to make it a bit more straightforward, so it's 3 minus root 8, or plus or minus root 8, I should say. So this one is going to be 3 minus root 8, and this one's going to be 3 plus root 8. I don't know if this is actually a negative. It's probably not a negative, is it, with root 8? Possibly not, but anyway, it doesn't matter. The point is we're looking for the outside part, so we're looking for the bit where P is less than 3 minus root 8, and the part where P is greater than 3 plus root 8. Okay, and it's really important you have that inequality, otherwise you're never going to get these, you're just going to get stuck with the previous one, which actually doesn't really work, because P isn't greater than 3 minus root 8, P is less than 3 minus root 8. So you need this diagram to help you figure out where the actual solutions are going to lie. Okay, and that is question 5.